Hi, this is Maggie. In this video we're going to answer the question, how do I convert a decimal number to a binary number? If you haven't already watched the videos that answer the questions, what is a number base and what are binary numbers, I suggest you watch those videos first and then return here. The algorithm, or series of steps, for converting from decimal to binary is not difficult to follow. However, make sure the algorithm makes sense. That is, make sure you understand why you're following the steps that you're following. If you understand why and how an algorithm works, it is easier to follow the algorithm, easier to remember the steps, and easier to adjust if an unexpected situation arises. Let's convert the decimal number 500 to binary. The final result is going to be a series of ones and zeros, with each position representing a power of 2. To convert a binary number to decimal, you add up the positions with ones in them. So a binary number is a combination of powers of 2 that add up to the decimal number. We need to find the exact combination of powers of 2 that make 500. The way to do that is to start with the largest power of 2 that is close to 500 but doesn't go over. That's going to be 2 to the 8th, or 256, because the next power is 2 to the 9th, 512, which is too large. So we put a 1 in the 2 to the 8th position. Now we need to figure out how much is left of our original number that we need to represent. We've taken care of 256, so we subtract that from 500, giving us 244. And now we repeat. What is the largest power of 2 that doesn't go over 244? That's going to be 2 to the 7th, or 128. So we put a 1 in the 2 to the 7th position and subtract the 128 we just added to our binary number from the 244 we were representing, giving us 116. And we repeat. What is the largest power of 2 that doesn't go over 116? That's going to be 2 to the 6th, or 64. So we put a 1 in the 2 to the 6th position and subtract 64 from 116, giving us 52 left to represent. Before you watch the rest of the video, I suggest you pause it and see if you can finish the conversion, and then come back and watch me complete it. Welcome back! So we have 52 left to represent. The highest power of 2 that isn't larger than 52 is 2 to the 5th, or 32. So we put a 1 in the 2 to the 5th position, the 32's position, and we subtract 52 minus 32, giving us 20, and we repeat. The next power of 2 is 2 to the 4th, or 16. So a 1 in the 2 to the 4th position, and we subtract 16 from 20, giving us 4. Now 4 is 2 squared. That means that we aren't going to have a 1 in the 2 to the 3rd position, or 8th place. So we put a 0 there. We put a 1 in the 4's position, and then we're done. 4 minus 4 is 0. So we put zeros in the 2's place and the 1's place, or the 2 to the 1's place and the 2 to the 0's place. Our final number is 1, 1, 1, 1, 1, 0, 1, 0, 0. I'm going to leave it as an exercise for you to convert that back to decimal to confirm that we have calculated this correctly. To do that, you simply add up the positions with ones in them. So to get you started, we have a 1 in the 4's place, the 16's, the 32s, 64s, 128, and 256's positions. You can also check your work in Python. A program called idle comes with your Python installation. Run idle, and at the prompt, the 3 angle brackets, type bin, all lowercase, open parentheses, and now type 500, our decimal number for which we want a binary representation, close parentheses, and press enter. When we press enter, we will get the binary conversion of the decimal number, prepended with 0b. Practice converting decimal numbers to binary and check your work both by hand and in idle. When you are confident you can successfully convert any decimal number to binary, you're ready to move on.